Okay, everybody, just a real quick walkthrough. I wanted to give some feedback on this problem. Many of you did a great job on this problem and nailed it. Some people made a few mistakes here and there. So I just wanted to go over a couple things so that if you struggled on this or you didn't do it quite right, you can go back and see how to do this hypothesis test correctly, because many of the mistakes that people made here are going to make the same mistakes on the video project, and then you're going to get dinged for it for doing it incorrectly on that video project. So what we have here is, as of 2023, 21 out of the last 31 presidential elections were won by the tallest candidate. So what we want to do is be able to figure out, is that an unusual number? Is that enough of a bias for us to think that there's something going on here, that people, whether consciously or unconsciously, are in fact voting for the tallest candidate? There's something about them that makes them vote for the tallest candidate. This doesn't give us an explanation. This doesn't give us a cause and effect. This just tells us, do we have reason enough to believe that this isn't just random chance, right? Is there some kind of bias going on here for taller people? So mainly I want to make sure that you set up the hypothesis test correctly, because that's what you have to do in the project. So you're going to come here, you're going to conduct your hypothesis test to support your argument, include all important parts of a hypothesis test, including a statement of your null and alternative hypothesis in both word and symbol form. Fully explain your test and interpretation. That's what you're going to have to do on the final. You want to hit all those pieces. That's why we're doing these project assignments, is to set you up for doing your project video at the end of the semester. And I give you a hint here. Do not use your sample proportion as your null hypothesis. There's a tendency for people to do that, and if you stop and think about it, it doesn't actually make any sense. For the logic of what a hypothesis test is doing, the hypothesis test, the evidence that you put into the hypothesis test is your sample proportion. So you can't use the fact that you have a certain sample proportion to verify if you got a good sample proportion. That doesn't make a whole lot of sense. What you want to do, and many of you got this right, is we want to compare the sample proportion and ask, how unusual is it that we got this sample proportion compared to some other proportion? Well, if there was no bias for the taller candidate, then what would happen is you would expect for the taller candidate to get elected about 50% of the time. So the proportion would be 0.5. Right? When you flip a coin, it's a fair coin. So you expect that, if you flip enough times, the proportion of tails is going to be 0.5, because it's equally likely heads or tails. Well, if it's equally likely that the taller or shorter candidate is getting elected, then your proportion should be 0.5. So that's what we want to set up in StatCrunch, or however it is that you went through. I looked at the work. A lot of you did some great work in setting up your hypothesis tests. I'm just going to use StatCrunch to make this quick and easy. So we go through. We've got our number of successes is 21, right? It's 21 and 31. Yep. Number of successes, 21. That's the number of times that the taller candidate got elected, which means P is the proportion of the taller candidate getting elected. We have 31 observations. Now, our hypothesis, the null hypothesis, is that there is no difference between shorter and taller candidates getting elected. If that's true, then P should be equal to 0.5. The proportion would be 0.5, like a fair coin getting flipped. Right? So that's what we're asking is, let's assume that there is no preference for taller or shorter candidates. What is the probability that we would see the taller candidate elected 21 out of 31 times? That's what their p-value is giving us. That's what we're trying to figure out, right? And then what we really want to know is if the p-value is larger than 0.5. So we're going to go through, hit compute. We get our value, we get our p-value here, and that is below the 0.05 cutoff that we generally would use in this situation, meaning we should reject the null hypothesis. So we reject that the true proportion of times that the taller candidate is elected is not 0.5, right? We're rejecting the null hypothesis. So that leaves us the alternative hypothesis that says, we have reason to believe that the taller candidate is going to get elected more than half the time. Okay, and some people were confused about this, saying, well, that doesn't mean they're going to get elected every time. That's true. It doesn't mean they're going to get elected every time. It means that there is some force kind of pushing things in that direction, some subconscious bias among people or something that is pushing things in the direction that the taller candidate gets elected more. We don't fully understand why that is, how it's occurring, or why. We just have statistical evidence saying that it is. Okay. All right. So please think about that and make sure that you use that when you set up your hypothesis test in the project video. Okay. Thank you.